Okay, so I'm going to make a little video walking through some of the answers from the review in case you didn't have your review completed when I went over it in class and so you didn't know what questions to ask. Now maybe some of these questions will be answered for you through this video, and you can also come to tutoring Monday morning. Okay, so when we have a table with all the values, then you should just enter those in your calculator and let your calculator give you both the sketch and then the information for the distribution. So to enter those, you would hit Stat and then Enter for Edit, and you would enter those in. To make the box plot, you would hit Second, and then that Y equals would bring you, second Y equals brings you up your stat plot. You want to make sure it's on, first of all, and then that you select the fourth icon, the one that looks like a box and whisker plot with the outliers shown. Otherwise, it won't show you the outliers. And then you're going to hit Zoom 9. When you bring up your graph, you can sketch it and you can hit Trace, and it will tell you where all these points are. It will tell you that this is an outlier at 94. It will tell you what this fence is. It will tell you your Q1, your median, your Q3, and your upper fence, which happens to be your maximum since there's no outliers up here. You can also go back to your home screen and hit Second Quit. Go to your home screen, hit Stat, arrow over to Calculate, and then Enter, and that will bring up all your statistics, your mean, your standard deviation, your min, max, Q1, Q3, all of that kind of stuff, so that you can have those actual numbers there, because most of them will occur on your box plot, but your mean and your standard deviation will not occur on your box plot. Oops. All right, so then we're just going to, when I say describe the distribution, that means cuss. So that means center, unusual features, meaning outliers, gaps, any of that kind of stuff. Center can either be mean or median depending on, remember you want to use median if it is symmetric, median if it's skewed, mean if it's symmetric. Shape should include unimodal, bimodal, whatever, and then it should include symmetric or skewed, and then spread. And spread should either be your IQR, median and IQR if you are skewed in any direction, mean and standard deviation if you are symmetric. So because this one is skewed, I let you put both of them, the mean and the median, but the median would be a better representation there. Same thing, the IQR would be a better representation because of the skew. But you can list them all, as many as you want. Okay. All right. Here we go. So here we are creating with only summary statistics, so you can't put that in your calculator. So you have to do it by yourself. So we want to find the IQR. So we did this one in class, so I'm just going to go over it briefly. You found your IQR by subtracting Q3 minus Q1. And then to see if it's an outlier or not, you do 1.5 times the IQR. And that tells you how long your fence is. So if I know here's my Q1 and here's my Q3, this number tells you how far can you stretch out. So I'm going to stretch out 1.125 places. So from Q1, I'm going to stretch backwards 1.13 places. From Q3, I'm going to stretch forward 1.13 places. And that lets you know anything outside that fence is an outlier. Anything inside is fine. So I can tell when I did that here, you can see kind of the notation marks around the side. I have a little outlier here at just that minimum 96.6 is just barely outside of my fence. But here, my maximum is a very large outlier. It's way outside. So that's going to skew me to the right. So we have a higher outlier, so the mean should be higher than the median, because remember the mean follows the tail. So if you were to put this like this, it would be skewed this way. So the mean would be out there and the median would be here. So the mean would be higher. Okay, so then would any of these be? So you just go back and you recheck your fence. 96.7 could be an outlier, but you'd have to recalculate everything given these these three new numbers, but it could be. These two are not outside the current fence, so they don't have any choice of being an outlier. Okay, so for these questions, we are just comparing side-by-side box plots. So who's the youngest? You just want to go down to the absolute youngest would be the passengers, and it looks like it's an infant of some kind. It's between 0 and 1, so the youngest would be maybe a newborn. The lowest median, remember that bar in the middle is your median. So cyclists and passengers are pretty close together, but it looks like passengers just a little bit lower, maybe 21, 22, somewhere around there. Smallest range would be the overall from top to bottom. So that looks like it's cyclists. I might estimate that to be 53, 54, whatever you said. This one, maybe like 11 or 12. So then what would be the range? I would just subtract. So I estimated these two numbers, so I got a range of 42. If you estimated slightly different and you got a range, if you said about 40, that's fine. If you said driver at 72, that would be incorrect. But I just want to see that you kind of are on the right track. I guess I still need to see these graphs here. Largest IQR, so that would be from Q3 to Q1. So that would be pedestrians, and again, I estimated 62 to 21. So you subtract Q1 from Q3. So I said about 41. Anywhere in that range would be acceptable. Which role generally involves the oldest people? So again, I would give that to pedestrians. They have the highest median, they have the highest IQR. So since this driver category is skewed and the passengers is skewed, these are outliers. Since it said generally, I would go with pedestrians. If it said who had the highest, then I would go over here with the driver out there. But generally means you're probably going to use your summary statistics, your median and your Q3. And then there's that explanation. Okay, so again, we're comparing side-by-side box plots. This question A is not written very well. Who had the lowest cumulative GPA? So there's kind of two ways you can interpret this. The questions in the test are much more specific. So either way, though, the answer is the juniors. On average, the juniors had the lowest GPA because their median is slightly lower than the seniors, and they had a lower minimum value. So either way, you're going to say the juniors. What is the approximate value? So if you interpreted it on average, you would say, hey, their median is about 2.9. Or you could say they had the lowest minimum at about 1.6 or something like that. So not very clear, but either way, we're going with the juniors on that one. Which class had the highest median? Remember, median is the bar, so that would be the sophomores with a 3.25. Largest range, again, back to the juniors. Everybody's maximum looks about the same, but the juniors have that low minimum there. So a maximum at 4 minus the minimum at 1.6 gives us a 2.4. Again, if you're just close to that, but you estimated slightly different numbers here, that's not a horrible thing. Which class has the most symmetric and the most skewed? So when you look at symmetric, there's kind of two things to look at. You want to look at both the box and the tails out there. So since the seniors, they have a fairly symmetric box, maybe it's the median's a little low, but look how symmetric their tails are, so that's good. Whereas, so I'm going to say that they are the most symmetric, because look at the juniors. Their box is even further skewed. Whereas the sophomores, they have one tiny little tail and then one long tail. So they're going to be the most skewed. Okay, this question was the same question that was on your chapter 6 question pack. So hopefully this one just came right out there. You can take these, you can either do them by hand or you can put them in your calculator. If you put them in your calculator, you have to put them all in. So you'd go to stat edit and you'd enter your list. There's one 1200 guy, one 700 guy. There are 6 400 guys. So you'd actually have to put those each down. 400, 400, 400, 400, 400, 400. and 4 500s. You have to put those separately, otherwise it's not going to work. So then once you had them in, you could go back to your home screen, stat, calculate one variable statistics. The mean is 525, and you'll have to scroll down to get the median at 450. Or you could do it by hand. Add them all up, divide by 1, 2, 8, 12. Divide by 12, and you get 525. Remember to find the median by hand. You just cross them out in order. Not this guy, not this guy, not this guy, not that guy. And you just work to the middle. The middle happens to be between 400 and 500, so you take the average and you say it's 450. How many employees earned more than the mean? Well, the mean was 525, so there were only 2 that made more, the 1200 guy and the 700 guy. Which measure of center best describes the distribution? Well, this is, if you plotted this distribution would be skewed to the right because you have a bunch of 400 and 500s and you have one 700 and one 1200. So anytime you have a skewed distribution, your median is always better. You can also tell now that I have both numbers, there's a lot more guys making around 400 and 500 than there are making above 500. So either way you want to interpret that would be correct. Okay, this last comparing box plot is the same as the other, so I'm not going to go through it. Same thing on A. That's a poorly worded. I said the Wren because they have the lowest median. If you said this Pipit guy because he actually has the lowest value, that's fine too, as long as you're going to justify. And again, the ones on the test will be more certain. You'll know what I mean. Okay, and then this last one, again, you've seen one of these exactly like this on your question pack, so hopefully you can go back and look at that too. So remember, we want to label with the 68. We start with our median down, we start with our median down the middle. Our mean, is 20,000, and then we move up by the standard deviation. So we add 1, we add 2, we add 3. We subtract 1, we subtract 2, we subtract 3. So the rule is 68, 95, 99.7. So within 1 standard deviation should be 68% of your data. Within 2 would be 95%. And then within 3 would be 99.7%. Okay, we did this one in class. 20,750 is 3 standard deviations away. So from here to here, I can see that's 99.7% of the data, which means that there is 0.3% of the data outside of that on the tails. Well, there are 2 tails though, so I have to half it. And 0.15 would be on the top and 0.15 would be on the bottom. So that's where I got the 0.15. What percentage is between 19,500 and 20,500? Well, my eraser is not very good here. All right, so 19,500 to 20,500, that's within 2 standard deviations. So within 2 standard deviations is 95%. Okay, and then we start running off. Well, for this one, you could do either way. Top 16%, you could either use the 68 rule, just the same way we did a second ago with this A. So 100 minus 68 is 32, and then you divide it in half, so each one is 16. The top half is 16, and the bottom half is 16. So I could tell that that's that 20,250. If that's confusing to you, you can do this problem using your calculator. It gives you a percentage, so you can do inverse normal. Remember, when it says top, you have to do below. So if it's 16% above, then it's 84% below. Let's see what that works out to be. It will spit you out a z-score of 0.99. So then you set that up in your formula and you solve it out, and you would get about this same number. So your model is meant to be a shortcut, but if it makes it confusing for you, then the long way will always work. So either way, you should get about 20,250. Okay, we also did this light bulb question in class, so hopefully that will, you'll remember that. I said you could actually answer either question as long as you explained it right. So you could either say that the standard has a better lifespan because he's 1.5 standard deviations above the mean, which means he actually did better than he was supposed to. He did 1.5 times the standard deviations better than he was supposed to have done, whereas the soft one only did 1.43 better than he was supposed to do. So that is what this one is saying right here. Or if you wanted to take kind of a common sense approach, you could go the exact opposite way. You could say that the soft white has a better mean. He's supposed to do better, and he has a lower standard deviation, which means he's not going to vary as much on you. So he is more often going to be more consistent, and he's going to be better at his job. So either way you want to take it, this one had a wild hair and performed better, or this one will consistently perform better. Whatever, as long as you express to me that you know what these z-scores represent, then that is what I'm happy with. Okay, this is sort of the same story, except for the question says which is more remarkable. So more remarkable means more unusual, means higher standard deviation. Means higher z-score. So the higher the z-score was more remarkable. Okay. All right, so we have a mean arrival time of 7:22. And they're supposed to arrive at 7:30. So what percent are late? So you're just going to do it normally. 7:30 minus 7:22 divided by 4 gives me a z-score of 4. If I do in my calculator second distribution and I do normal CDF, I want to start at a z-score of 2 and I want to go until the end of the graph. So I'll say 99. And that will give me at about 2.5% there. Okay, now we hear that they need 5 minutes to adjust before they are ready to actually work. So if they have to adjust before they can start to work, then they better arrive at 7:25 so that they have 5 minutes to adjust before the 7:30. So same question, only now I'm doing it from 25 instead of 30, which gives me a z-score of 0.75. I do the same thing, but this time it says what percent make it early enough. So that means all these people arrive early enough. So I am going to, this time, I'm going to do from the bottom of the graph up to my z-score, and 77.3% arrive early enough to be adjusted and ready to work by 7:30. Okay, so last set anyway. So we have, for the chemistry, we have a mean, we have a mean of 50 and a standard deviation of 18. So find a z-score for 75 and tell what it means. So I just put it in my formula, 75 minus the mean over the standard deviation, and that is a z-score of 2.5. All z-scores tell you how many standard deviations above from the mean are you. A positive z-score means you're above the mean, a negative z-score means you're below. So 2.5 means I am 2.5 standard deviations above the mean because it's positive. Most of you got that right on your quiz, but you just said, oh, I got -2. You didn't tell me what that means, so make sure you interpret it. That's how many standard deviations and which direction you are, above or below. Okay, 40th percentile. When I give you a percentile, you have to go backwards. So you're going to do inverse norm of 0.4. That will pop out a z-score for you that you can put in the formula and solve backwards for x. Solving is always the same. Multiply by the standard deviation and then add the mean over. And that will give us 47.5. And since the mean is 50, 47.5 seems like an appropriate answer there. What proportion of students will have a raw score less than 45? So find your z-score. 45 minus 50 divided by 10 is a z-score of -0.5. So then I'm going to go to my calculator, normal CDF. I'm going from less, so I'm going from the end of the graph up to my z-score. Press enter, and then your percentage will come out. Between 30 and 65 means I have to do the problem twice. Once for 30, once for 65. So for 30, I got a z-score of -2. For 65, I've got a z-score of 1.5. So then I can put that in my calculator. CDF from -2 all the way up to +1.5. Who's in between there? And your calculator will tell you it's 91%. What is the cutoff score for the students who have the highest 20%? Anytime I give you a percentage, you have to do inverse. Remember, if I say highest, your calculator only does lowest. So the highest 20% would be the lowest 80%. That would give you a z-score of 0.84. And then we solve backwards. So times 10 for the standard deviation. Add 50, and that gives me 58.4. This one is the one that was confusing people on both the homework and this review. The central 90%, you really need to draw a picture for this. I know y'all get so irritated when I tell you to draw a picture, but I'm not torturing you. I'm actually trying to help you. So the center 90% means that I have left off 10% of the values. Well, that means half the values are below, so 5% are below, and half the values are above, so 5% are above. So I am going to do my inverse normal for 5%, and that'll get me a z-score of -1.64. Now, if you went and you did in your calculator to do the inverse normal for the highest 5%, it would tell you +1.64. But because these are always symmetric, take your negative value, and the positive side has to be positive because it has to be equal because this has to be symmetric. Okay, so once you have your z-scores, you plug it into your formula. You just have to do it twice. Once for the negative z-score, once for the positive z-score. You solve it out, and here are the cutoff values from 33.6 to 66.4. Okay, IQR is the exact same way, only you're looking for the middle 50%, not the middle 90%, but you do the same thing. You find your z-scores, one of them is negative, one of them is positive. You solve backwards. Oops, I didn't finish this one. And you get your cutoff range just like you did over here, but IQR, you actually do the subtracting. So 56.7 minus 43.3, and you get an IQR of 13.4.